Okay, this turned out to be some of this easier than I thought, some harder. In terms of planning it out ahead of time, I thought they were all good questions. I think you'll find that at least some of the videos there would be helpful. At least some of the starting ones, like the ones you watched, the two that you watched last week, the physics girl one where she did the mirrors. I think that's helpful, and the first Professor Dave one. So the other ones will kind of hang on to as we proceed. But what I came up with for this one was trans. So you got a CH3 here and a CH3 here, and these can't rotate because of that double bond. We talked about that at length, and I think you're on top of that. How you got this pi bond here, and that can't rotate. So you got a sigma bond between that's not indicated here, and then the tops and the bottoms, these are p orbitals. So between the two top and bottom sets, they have a pi bond that doesn't rotate. You seemed okay on that, so ask me if you have a question. But this reading is pretty good, very clear. So I don't think I need to go through that. But when we get into these ones here, where we talk about cis or trans, you have to talk about what is cis and trans. So looking at this one, these two fluorines, this end is the same. So if this, let's see, 1, 2, 3, this would be a propyl group. If it went off this way and you had a hydrogen here instead of the propyl group here and hydrogen here, it'd just be like flipping the thing over. So that would be the same thing. So I have down for B that it's not stereoisomeric at all. Okay, C, kind of depends on how you do it, but okay, there's your double bond. You have a hydrogen here, you have a hydrogen here. So you got this tert-butyl group there. And on this side you got a propyl group. They are trans to one another, even though they are not the same group. So I think that takes a little bit of description. They probably want the answer. Levi, we were talking about trans, probably does okay, but they're different groups, so just be aware of what you're talking about. Okay, on this one, D. Okay, so you got a double bond here, you got ethyl group there. On this side, you got a isopropyl group. There was two different groups, so you got a hydrogen here, hydrogen here. Those two different groups are trans to one another, so that's what I have for D. But it takes a little bit of description. Okay, what about tamoxifen? You see this one advertised. I think I've seen this one advertised on TV. This phenyl group and this phenyl group are trans to one another. I guess it depends on how you want it. So this is starts out as a phenyl group, but it's got more stuff on it, and this is a ethyl. I would say that this is going to be classified the way the book does this in trans if you're discussing those two phenyl groups, but you need to clarify that if you're having that discussion about this particular molecule. So why did I say cis? Probably just a mistake. I probably meant to say trans. Okay, F. Take a look at F. And again, I don't have any of these solutions at hand, so if you think I've got a mistake here, I go back and watch these videos and I find all kinds of them, but usually they're not really of much consequence. But if I've made a serious blooper, just let me know. I'll go back and look at it. F, so you got this double bond here. Off this side, you got 1, 2, 3, a butyl group. Off this side, you got 1, 2, 3, a butyl group. Off this side, you got 1, 2, 3, a butyl group. So it doesn't matter where this oddball goes. So that is not a stereoisometric situation there on D. No, that's F, I guess, not stereoisomeric. I said isometric, it should be a stereoisomeric. Now, by the way, Professor Dave, before I forget this, goes around saying, back up a page here. I guess it's on the next page, that's where I thought it was, but superposable is what he says. It's superimposable. Superimposable. But let's get to that when we get to that mirror image thing. F. Where he did. Okay, so aconitic acid, which is involved in metabolism. We've got, these are not all the same. We've got a carboxyl group here, COOH. Carboxyl group here, COOH. Okay, there's a carbon there with a carboxyl group on the end. That's not the same thing. So how would you do this one? I would describe these two carboxyl groups as being cis to one another. And that's an oddball with an H here. So I would probably call this one cis. That's what I have for G. Okay. Now, 5.2 took me a while. So identify the number, maybe it was 5.3. Identify the number of stereoisomers that are possible for a compound with the following constitution. Now, I guess this one did take me a while too. And I had these pieces drawn here. I came around to the eventual conclusion that here at this next to last carbon on this end, you could rotate this guy around. And on this end, you could rotate this guy around. And everything ended up being, or just put the hydrogen, switch the position of these two bonds and these two bonds, that you kept ending up with the same thing. So for 5.2, the number of stereoisomers, I've got 1 on that. Let me know if you get something different. But I kept rooting around with that and ended up with the same thing every time. Okay, compound X and Y. This is kind of hard. Compound X, if I put the double bond between the second and third carbon, so I have a trans, and this methyl group is trans to this ethyl group. Compound X. This is what I got for X. For Y, I got several things. I got, it took a while. So this is X up here. These are what I got for all Y. Now I could probably go through this in a few minutes, but it represents quite some time of work, and I get lost in problems. I can spend an hour or 2, 3 hours on a problem and not realize sometimes it seems like it's 20 minutes. But if I put the double bond on the end, that's one configuration. If I put the double bond at the second position, that would be, I could do 1, 2, 3, 4, 5. I got a lot of options. Well, let's put it back out on the end again. I can put a methyl group off of this carbon and an ethyl group off the carbon down here. So I could break that bond and leave a methyl here and take this ethyl down here and stick it, which is what I have here. Okay. I could, if I have that on the end, I could have my 3 carbons off of this, but shift it so that this carbon is the one attached and that one's free. So it's kind of like an isopropyl thing. Okay, so I've got that 1, 2, 3, 4, 5 carbons. And then I could move that carbon in a position to here, and then I would have, I could put them, then I could like take this off here and put a hydrogen here, take these 2 carbons off, split them and put one on one side here and one on the other. So there's 4 that I've got there. It says 4 possible structures for the compound Y. So it must be these 4. Now, draw those out and fiddle with them. And that makes it look easy when I just tell you what they are. But trust me, I spent a while on that. Maybe I'm not too imaginative on nights that I don't sleep well. Okay, so the next one was chiral centers. And I think that those videos I have you watch are really going to help with that. That's going to be tough for me to explain here, even with the models. But the videos do a good job with that. 1996, which is well after I took organic chemistry, they came up and called these chiral centers, but I think in my class we called them that anyway. So, like for example, here you've got an ethyl group, a methyl group, a chlorine, and hydrogen. That's 4 different things. That's what you need. A propyl group, ethyl, hydroxyl, and a hydrogen. That's 4. Here you don't have that. Well, no, here you do have that because you got bromine and a hydrogen off the back that's not there. One way around this ring, and then the other way is different. This one is the same way each way around the ring, so you don't have 4 different things. You got to have the carbon has to have 4 different things around it. Okay, this example is real clear. So, I thought. So if you're stuck on that, basically you have to have 4 different things around your carbon. So let's go around these one at a time. And what I have here, around the first one, somebody wrote in the book there, but I kind of ignored it because I figured, well, that could be wrong. So I'm going to basically, even though I redrew those and I looked past those, I'm kind of winging this. Because I think I can get by with that. But on the first couple, I did them. But as I redrew that, there's a carbon here, but it's got 2 hydrogens off of it, so that doesn't count. There's a carbon here, it's got this thing this way, this different thing this way, an OH this way that's different because that has a carbon there, and an H, so that's a chiral center. Okay, this carbon has 4 bonds. It's got this mess this way, a different sequence of the mess this way, this whole mess this way, and a hydrogen, so it's a chiral center. Okay, going around on this one, this is B. I don't think I was paying enough attention. This is not a phenyl group or anything like that. So there's a carbon here. Okay, let's start with this one. This carbon has 2 hydrogens on it, so that can't be the case. So I've got this ring this way, which is not the same direction as this ring this way. So this bond is different from this bond, is different from the OHs, and there's a H. So I think this is a chiral center, even though I didn't have it listed. Okay, this has 2 hydrogens, so we don't do that one. This has 2 hydrogens, we don't do that one. This doesn't have 4 individual different bonds. Okay, what about, do I have this drawn right? Okay, so there's already 1, 2, there's a double bond there, so that can't be a chiral center. That can't be a chiral center. That can't be a chiral center. You've got to have 4 individual bonds. This has got 2 hydrogens, can't be. 2 hydrogens can't be. 2 hydrogens can't be. Here you have a carbon. You got this bond this way, one this way that's different from this way, which is different from this ring. So that's a chiral center. What about this one? Did I draw it right? I have a carbon this way, which is different than this way. It's different from this way, and you got a hydrogen. I think this is a chiral center. I don't have it drawn already, but I think it is. Okay, what about this one? This ring this way is different from this way. You got that and a hydrogen. I think this is a chiral center. Okay, this way you got a group that's different from all of this mess, which is, and then you got a methyl this way and a hydrogen, so that's a chiral center. Okay, on this one you got 2 hydrogen, no, 2 hydrogen, no, 2 hydrogen, no. And these two groups are the same, so no. Well, I don't know what you come up with. That's what I come up with. And not double. Well, that's only the second time I've been through these two. Or the other ones I haven't done yet. Drawing in the book I've got, but I didn't look at that part. Is my drawing right? Okay, let's take a look at this. You remember what an SH is? That's a thiol. This guy is called captopril. It's used to treat high blood pressure. That's probably a trade name. Okay, so carbon there, but there's a double bond. Okay, carbon here. We got a mess this way that's different than this way, and that group and a hydrogen. I think you have one there. Yeah, chiral center there. 2 hydrogen off of that, no. 2 hydrogen off that, no. 2 hydrogen off that, no. This one doesn't have 4 individual bonds. Okay, so here we've got, I just drew in an H accidentally and then circling it out, and then it looked like an O, so I just smudged it real hard. But you got all this mess, and this mess is different, and a methyl group and a hydrogen. This looks like a chiral center to me. That's got 2 hydrogens, and no. Again, let me know if you think one of these is off.